Hello everybody, my name is Denis. I'm a postdoctoral researcher at the University of Helsinki, and today I would like to present to you our paper titled SIGIR Matter of Serendipity in Recommender Systems. Recommender systems are software tools that suggest items such as articles or videos to users. Let's say there is a user. His name is Johnny. Johnny likes articles on machine learning. We keep recommending to him only articles on machine learning, although these recommendations will probably be relevant and accurate. Johnny will probably find our system boring. That is why recommender systems are optimized not only for accuracy, but also for novelty, diversity, and serendipity. In recommender systems, the term serendipity has multiple definitions, with the most common being that an item is serendipitous if it is relevant, which means that the user likes it, novel, which means that the user is unaware of it, and unexpected, which means that the item is dissimilar to what the user usually consumes. Let's say that Johnny wants to find an article on machine learning, but finds an article on filmmaking. And let's say that he likes this article, let's say that he finds this topic novel, and this article is dissimilar to what he usually reads. Since this article meets all the requirements for Rexis serendipity, we mark it Rexis serendipitous. However, this definition is unnecessarily narrow, leading to many items that are serendipitous according to the original definition of serendipity being ignored. Originally, the term serendipity was coined by Horace Walpole in 1754 when he referred to the old Persian fairy tale, The Three Princes of Serenity. The author wrote that the princes were always making discoveries by accidents and sagacity of things which they were not in quest of. Since that time on, we started using this term in our daily life. Later, the sociologist Robert K. Merton collected mentions of the term serendipity from magazines and journals for investigation. And in 2018, based on archives of Robert K. Merton, Orchid Yakub proposed the serendipity topology, which included 4 types of serendipity which depend on whether the searcher had a particular problem in mind and what the discovery led to. For example, let's say I put on a jacket and find 50 euros in my pocket that I left there. If I had been looking for this 50 euros everywhere in my apartment and my jacket was the least expected place where I could find this 50 euros, that would be a serendipitous discovery according to one of these types. If I haven't been even thinking about 50 euros and I discovered them in my pocket, then that would be a serendipitous discovery according to another type. And if I had known that I have 50 euros in my pocket and I reach there in the pocket, find this 50 euros, then this is not a serendipitous discovery. And it's important to know that serendipitous discovery is also always beneficial to the user because it helps them to achieve goals. And we use these 4 types of serendipity and apply them to recommender systems. We refer to this type of serendipity as generalized serendipity, and we applied them as follows. An item is generalized serendipitous if it helps the user to achieve at least one goal different from those they set out to achieve with the recommender system. For example, let's say Johnny wants to find an article on machine learning, but finds an article on filmmaking. And we mark this article generalized serendipitous because it helped Johnny to achieve a goal which he hadn't planned to achieve with this recommender system. Generalized serendipity includes some cases that are also covered by Rexis serendipity. For example, Johnny liking an article on filmmaking. But it also includes cases that are not covered by Rexis serendipity. For example, let's say Johnny joins the system and he wants to explore novel topics. He wants to particularly find articles not on machine learning, but he finds an article on machine learning and likes it. This article is not going to be Rexis serendipitous because it is similar to what he usually likes. But it is going to be generalized serendipitous because it helped him to achieve a goal that he hadn't planned to achieve with the recommender system. We also looked at user definition of serendipity, which is user understanding of this term. We wanted to investigate this because we wanted to understand what items users are interested in when they request serendipity in a system. These were our research questions. To what extent do the various definitions of Rex's serendipity capture items considered serendipitous under generalized and user serendipity? How are relevance, novelty, and unexpectedness associated with generalized and user serendipity? And what aspects of user behavior are associated with different serendipity types? To answer our research questions, we ran an observational study in Soli, an article recommender system for iOS and Android. This application displays articles to users in an internal browser and crawls links to those articles every day from popular websites. This study was part of the development process of this application because one of the goals of this application was to recommend serendipitous articles to users. When the user first logs into the system, they are asked to indicate their interest, and every day we ask the user to tell what they are planning on doing with the system. What is their goal? And they can select goals from the predefined list of goals, for example, entertain myself or keep up with the news, or they can also add a custom goal. After that, they go to the hub page where they can see 15 article recommendations, 12 within their interest and 3 outside their interest. All these articles are picked randomly from these categories. After reading an article, the user can hit the done button and they are asked to reply to the survey. To measure Rex's serendipity, for example, we use the statements. I like this article, I gained knowledge, or I gained knowledge. If the participant replies agree or strongly agree to any of the statements, then we consider this article belonging to this concept. For example, if the participant replies agree or strongly agree to the statement, I like this article, then we mark this article relevant to this user. We also asked the participants to indicate goals that they achieved with the article, and we compare them to the goals that they indicated that they wanted to achieve with the application every day. And if they achieved at least one goal that was different from what they wanted to achieve, then we mark this article generalized serendipitous for this user. Participants can also interact with articles. They can hit the like button or bookmark an article. We recruited our participants in social media websites and ran this study for 16 weeks. Around 600 participants joined our study, and around 400 of them completed at least one goal or an article surveys. We focused on this 400 participants. And we had the parallel distribution of time spent in the system. Most articles were either completely read or almost completely read, and participants interacted with 20% articles. These are distributions of goals that participants achieved with an article and also they plan to achieve with the application. And coming back to the example of the journey, participants do prefer to explore novel topics sometimes. We also had one peculiar observation, which was that the goal improve myself was one of the most desired but the least achieved goals. The first key finding we had was that recommendations that should be considered serendipitous have been overlooked due to the narrow definition of serendipity in recommender systems. First, we can already see it from raw numbers. Around 2,000, so we received user feedback on around 2,000 articles. Around 1,000 of them were generalized serendipitous, around 700 of them were Rex's serendipitous, and around 800 of them were user serendipitous. Second, serendipity types only capture 2/3 of generalized serendipity. And to measure this, we used classification metrics, precision, recall, and accuracy. We also included various definitions of Rex's serendipity. For example, RealNov is a combination of relevance novelty, and RealNext is a combination of relevance and unexpectedness. We also noticed that relevance has the highest accuracy, which was surprising because relevance has been seen as antagonistic to serendipity. We ran two logistic regression models where relevance, novelty, and unexpectedness were our independent variables and generalized user serendipity were our dependent variables. And we found that for both generalized and user serendipity, relevance had the highest or the strongest association, novelty weaker association, and unexpectedness the weakest association. We also noticed that model fit for generalized serendipity is much lower than that for user serendipity, and we will also see from this model fit that relevance, novelty, and unexpectedness cover only, or describe only part of these concepts. So there are some other factors that we can consider. Our second key finding was that user understanding of serendipity differs from generalized and racist serendipity. In the best case scenario, serendipity types capture just over half of user serendipity. And again, we found that relevance has the highest recall. And our third key finding was that different types of serendipity are associated with different patterns of user behavior. For that, we run 9 mixed effect logistic regression models where interactions, reading progress, and time spent were our independent variables and serendipity definitions were our dependent variables. And we can see that these serendipity types have different patterns or they're associated with different user behaviors. Most serendipity types are associated with interactions and reading progress. Generalized serendipity is only associated with reading progress. The combination of relevance and novelty is associated with all the measured behaviors. Unexpectedness, here we haven't found evidence that unexpectedness is associated with measured user behaviors. And finally, we noticed that the model fit for user behavior was lower than that for racist components, suggesting that racist components better describe generalized and user serendipity than user behavior. Our study had 3 key takeaways. First, racist definition misses items that should be considered serendipitous, implying that algorithms optimized for one type of serendipity are unlikely to satisfy another. And also it's important to note that when we optimize for user or racist serendipity, we might improve user behavior, users will click on more articles or stay longer in the system, but we might not optimize for generalized serendipity, which describes the phenomena of serendipity, the phenomena of users achieving unplanned goals. And second takeaway is that user understanding of serendipity differs from generalized and racist serendipity, implying that optimizing for serendipity might not meet user expectations of the system. And finally, we noticed that serendipity covers many serendipitous items, which is surprising because relevance has been thought to be antagonistic to serendipity. With this, I would like to end.